Hello my dear students, welcome to 9th standard online classes in our YouTube channel. Myself R.V. Jambagi. In the previous period, we studied how to plot the graphs in different circumstances for distance time graph as well as velocity time graph. In today's lecture, we are learning the kinematic equations of motion. We are learning kinematic equations of motion. In today's lecture, we are getting what exactly these equations represent, what are those equations, and what is the importance of those equations. Probably we will derive one of the equations of motion. Okay. So, first one, that is our first part, you may say. What is the meaning of these equations? When the object moves along a straight line, assume this is, if the object is moving in straight line along with the constant acceleration or uniform acceleration, it is possible to relate velocity, acceleration, even the distance along with time by a set of equations, called as kinematic equations of motion. So, when the object is in a straight line with uniform acceleration, it is possible to calculate the acceleration, velocity, the distance traveled by the object, or you may take displacement along with the time. Okay, by a set of relations, the set of equations called as kinematic equations of motion. In simple manner, we call equations of motion. Which means equations of motions, kinematic equations of motion, all are same. Okay. So this is about equations of motion is concerned. There are three set of equations of motion. They are V equal to U plus AT. V is equal to U plus AT. This is called velocity time relation. It is called velocity time relation. S is equal to ut plus half at square. S is equal to ut plus half at square. That is called as position time relation. And the third one will be V square is equal to U square plus 2as. In some books they have written V square minus U square is equal to 2as. Both are same. Okay, that is known as a position velocity relation, where here U is taken as initial velocity of the object, V be the final velocity of the object, A be the acceleration, T be the time, and S be the distance or displacement, or you may take any height of the or any length of the object. So these are the three important equations of motion. So first one is taken as a velocity time relation. Equation is this. Second is the position time relation. So the equation followed by this. Then position velocity relation, which is given by this. I hope you are getting the orders right. So the next point, that is importance of equations of motion. In physics, equations of motion are the equations or the relations that describe the behavior of physical system, in terms of its motion along with time. So these are the equations that describe the behavior of physical system. Behavior of physical system in terms of its motion along with time. Then what is the physical system? Physical system, for that let us imagine a car is moving on a straight road. Okay, so here the car which is moving in the environment of road, and we are observing that. Okay, that is taken as physical system. The motion of the car we are analyzing, so that is called as physical system. It may be environment, if you are getting the motion of the objects in the environment is also taken as physical system. If you are observing the motion of the celestial objects such as stars, even galaxies, and sometime planets like that. Okay, so all they are belonging to a system called as physical system. I hope you got the meaning of physical system. So the physical system is a system in which we are getting the motion of the object along with the time. So we are looking in that prospect. So these are the, as I mentioned that, these equations describe the behavior of physical system in terms of motion and time. So these equations help us in calculating the acceleration of any object. If a car is moving, you can find the acceleration of that car. So we consider car as an object. You can get the height of the larger objects. So we are already aware that if the scale is small, you can measure with the help of centimeter scale. If you want, you even go below that. Okay, so centimeter, millimeter, like that. If it is in meter, you have meter scales. And what happens if the distance or height or whatever length exceeds that limit? Then these equations are helpful. Again, the heights of the larger objects or things can be done using these equations, and you can calculate the speed of the objects. You can calculate the speed of the objects. As I said that it may be a car, it may be any vehicle, it may be a flying bird. Okay, so these are all the things we are these equations called kinematic equations of motion. So we are proving those equations one by one. The first amongst that, to prove velocity time relation, that is v is equal to u plus at. We need to prove this equation. How v is equal to u plus at? For that, let us consider the velocity time graph for the object which is in uniformly accelerated motion. I am bringing the object which is moving in uniformly accelerated motion. So that is given by this graph. So that is known for us. So the velocity time graph should be like this. We are considering the velocity time graph for an object which is moving in uniformly accelerated motion. We took it from the origin. For calculation of the equations, we need to adjust some things. For that adjustment here we took not from 0, just from the certain height. Okay, so some adjustments are required to simplify the problem. Okay, so this is for the object moving in uniformly accelerated motion. So what next? So you need to complete this point on x-axis here, and so you are drawing this these dotted lines to x-axis and call this point as C. You call this point as C, and similarly you do couple of parallel lines. So you call it as D and this as E. So here what we have done, we done the adjustment by that BC perpendicular to x-axis, and we drawn again AD perpendicular to y-axis, similarly BE perpendicular to y-axis, by that BE and AD or DA parallel to one another. We adjusted as per our need. So we drawn, what we drawn, BC perpendicular to OC here. Similarly you can say DA perpendicular to OE, you may take DA perpendicular to OE, and later you took BE, which is again perpendicular to OE line, or you may say that BE parallel to DA. We have done some adjustments, by that we can reach the problem. So here, considering from point O to point B, the object is in motion already, and hence you can write it as initial velocity. This region is taken as initial velocity u, and the object at the end will be B, and hence BC will be our final velocity v. BC our final velocity v, and you can take this point O to C as your time t, and you can rewrite this portion BD as V minus U, BD as V minus U. I will tell you how V minus U appears. Okay, so these are the initial velocity, final velocity, and time, along with the differences in final and initial velocities. From the graph, as I said, this BD can be written as this portion entirely. Therefore I am writing first BC, which is equal to BD plus DC, BD plus DC. Okay, BC is equal to BD plus DC. How? This is entire portion B to C, that is BC, which is comprises of BD plus DC. And we are also considering and DC, which is parallel to AO. Okay, you can write from the graph BC, this portion BC, which is equal to BD plus DC, and this DC, which is parallel to AO. So here you can write here BC is equal to V, and DC, which is equal to, since it is parallel you can write equal, AO, which is equal to U, and OC is equal to T, and OC is equal to the time taken by the object, that is T. So substitute these values, You can give it as equation number 1, which will help you, equation 1. So values in equation 1, we get V, which is equal to BD plus DCU. Therefore, you can write BD is equal to V minus U. So this is how V minus U comes here. Okay, BD is equal to V minus U. Call this as equation number 2. So once you got this equation, now we are finding the acceleration. We need to calculate acceleration because we covered V, U, T. So we need only A. Therefore, you can write the acceleration is given by acceleration A is equal to, that is change in velocity of the object with respect to time. So you can write it as A is equal to BD divided by dA. So this is nothing but the slope y by x, that is a slope here in the graph. So that is BD dA. Okay, that is the slope of the VT graph. The slope of VT graph gives you the acceleration. Therefore, A is equal to BD by A, and from equation 2 you have BD, and you need to calculate dA. Remember here dA, which is parallel to OC. Here dA, which is parallel to OC, and hence you can write dA is equal to OC, and OC is equal to time t, and hence you can write acceleration A is equal to BD is use equation 2 V minus U, and for dA, which is equal to OC, which is equal to t, and hence you can write V minus U by t, and you can rewrite it as sending t on this side and adjusting this equation. Just you make a step one more, no problem. So A into t is equal to V minus U. Therefore, you can write, V is equal to U plus AT. Therefore, V is equal to U plus AT. This will be your first equation of motion. This is the proof for the first equation of motion. So for that, what we consider, let us try to summarize that. What we have done, we just took the velocity time graph for the object which is in uniformly accelerated motion. For that, we just made one assumption that the object is already in motion. We are not taking it from the origin, assuming it has some velocity already. So we took from point A to point B, and what we have drawn, BC perpendicular to OC and DA perpendicular to OE, and we took that BE parallel to DA, and later we took DA parallel to OC. So from the graph you written BD is equal to, this entire part BC is equal to BD plus DC, that is this portion BD plus DC, and we took DC parallel AO. So from the namings already, AO as U, BC as V, and we need to calculate what exactly the BD is. Okay, so BC is equal to V, DC, which is equal to AO actually, and which is equal to U here, and OC is equal to T. Therefore, V is equal to BD plus U, and hence BD can be written as V minus U. Call that as equation 2. And so the left out point is only the acceleration. We defined the acceleration as change in velocity by time, and hence that will be the slope. Slope is BD divided by DA. So BD is equal to V minus U. DA, which is parallel to OT, and hence OC, and hence that is equal to T. Therefore, AT is equal to V minus U, and hence V is equal to U plus AT. This is how we proved the first relation. And at this point of time, I am saying, if you are having any doubt, make use of my WhatsApp number, ask the questions, by that I can reach you people easily. Okay, don't take the doubts into your mind. So please try to throw those doubts in front of us, by that you will get the solution for that kind of problems. Okay. I am going to pause here at this point of time with proofs for the rest of the two equations of motions in the next period. Till then, take care of yourselves along with your family and friends under the coronavirus pandemic situation. Bye-bye.